again, we're just going to touch in on it briefly for now, because this is a very complicated area. 38% of the sensory input to your brain comes from this area right here. So, yeah. And it's one of the earliest sensory tracts to innervate, and that's why when babies are born, they want to put everything in their mouth. Mm-hmm. Is that's how they experience the world, by how it feels in their mouth. And that's also why your teeth can discern a 1/5000th of an inch difference in there, because there's so much innervation that. So have you seen a diagram? What's called the homunculus? Any textbooks?
Yep.
Yeah. So a homunculus is basically if you drew a picture of a body proportional to how many nerves go to the sensory cortex for it. You know, you've got this big head with these huge lips, right? Little tiny trunk, great big hands, great big feet. Yeah. So, and you can test that out for yourself. If you take, say, like two needles, and in your hand hold them a couple millimeters apart and touch your arm with them, and move them together until they feel like one. You can't tell they're two needles anymore. Okay. If you look at it, they're still fairly far apart. So then you take that same distance, you touch them to your fingertip, and you keep moving them together until it doesn't feel like two anymore, and they're going to be fairly close together. But then you take those and touch them to your lip or your tongue, and you'll still feel two tips. And you move them together until it feels like one, and they're almost touching. So that shows you the different levels of sensation, you know, just certain discrimination. So, but anyway, so this area is very, very, has a huge say, essentially, on what goes on in the brain. That's one way to think about it. Because the sensory input gets so much press, so to speak. And so the mandible, most mammals, the mandible is two halves. So if you go out in the woods and you find a deer jawbone, what do you find?
Two pieces.
Yeah, if you're lucky, usually you just find one of the pieces, right?
Well, yeah.
Yeah. But they're either two pieces or one. You only find one. But so most mammals have a suture here in the middle. It's called the mentum suture. And the reason they have that is their jawbone, their jaw muscles are so strong that if there wasn't a shock absorber here, they would be breaking their jaw just chewing on things. So if you ever wondered why a dog can chew through a bone and you can't, it's because, and chimpanzees can, but humans can't. There's actually mutation in the gene between humans and chimpanzees that give us really weak jaw muscles. So it's genetic. And so, because our jaw muscles are so weak, we're not going to break our mandible when we bite down. It's confused. So, makes it a little more stable. But yeah, if you look at the bobcat, for example, I had to glue it together or else it would always fall apart. But that suture's open there. The mentum suture. So, because it's got lots of jaw muscles. I mean, most of its skull is covered in jaw muscles. If you look at the ridge of attachment. So, I'm not going to go into all the different muscles that attach the mandible because you know all your cheek muscles do, and the floor of the tongue. We'll cover that later. But the two muscles we're going to work with today are the masseter and the temporalis mostly. Okay, so your masseter is responsible for a lot of the power in your bite when you're really chewing down hard, and the temporalis is responsible for quick movements of your jaw so that we can talk and sing and stuff. So really quick movements don't usually have a lot of power behind them. Once you slow down, you can really bite down. Right? Not compared to a bobcat, but. And then the mandible articulates with the temporal bones, and functionally, each place the teeth connect is also an articulation. If you think about it that way. So when you close your mouth, wherever your teeth touch, that's also an articulation. So the mandible also articulates with the maxilla through all these articulations here. Okay? And most people have two maxilla because the suture between the maxilla don't fuse. Okay? So there in your handout is a diagram of the anatomy of the TMJ. The most important thing I want you to understand about the TMJ right now is that it's the only joint in the human body that's designed to dislocate during normal function. Okay? So we're not that different from snakes, actually, in that regard. We have legs, but... So if you put your finger right in front of your ear, and open and close your mouth a little bit, if you open and close your mouth just a tiny bit, like when you're talking, you feel it kind of rocking a little bit, but if you open your mouth real wide, what do you notice? It pops open and leaves a hollow behind, doesn't it? Mm-hmm. Yeah. So under normal talking conditions, the joint just rocks, and it's a barrel-shaped joint with the long axis of the barrel going this way. It's not a ball; it's more like a barrel. Okay, which gives it a little more surface area, and it can rock like this. And then when it opens really wide, and this model doesn't do it very well, but that thing pops forward like that. Okay. So the articular cartilage in here has to be movable. And so how it works is there's like a plate of cartilage there, and it's got muscles on the front, usually these lateral pterygoid muscles that run from this lateral pterygoid process over to the cartilage. When you open your jaw, the lateral pterygoid muscle pulls the cartilage with the condyle, and then when you close your jaw, there's an elastic band on the back of that cartilage that pulls it back in. Okay? So muscle pulls it out, elastic band pulls it back in. So what do you think happens if you're carrying a lot of tension around in your face and you open your jaw really wide?
Does it have elastic back?
Yeah, so when you go to close your jaw, the muscle is tight and it keeps that cartilage out here and your jaw goes clunk, and then you're biting down on that elastic band instead of on the cartilage. And that elastic band has a lot of pain fibers in it. So a lot of people get clicking and popping in their jaws, you know, and that's a fairly common side effect from clenching your teeth in your sleep, which creates a lot of excess tension in these muscles. And so I personally think that the cranial work's one of the treatments of choice for bruxism and TMJ problems, because we can get in there, relax those pterygoids, and show them how to get that cartilage back into place. And there's a couple different self-help techniques that are in your handout to do that. One of my favorites is well, you can use a wooden dowel that you just cut to be a little bit wider than your teeth. And you put it back here on the second molar, like that, and then you go and you put cranial amount of pressure right here on the tip of your chin, point your chin that way, and look how that just rocks those condyles open.
So you're doing like a chin lift kind of move?
Yeah, you're just kind of pushing on your chin gently with like a piece of wood or something in your mouth. But it's like a what am I trying to think of the word, like a teeter-totter with it.
The fulcrum?
Fulcrum, yeah. You make a fulcrum on about the second molar back. And in about a few minutes, just a few minutes of very light pressure, people's pain and spasms can be alleviated. And then oftentimes too, that will allow that cartilage to pop back into place, but they haven't destroyed that little band too much by then. So that's a good self-help technique. A guy came through my office a few years ago that had taken, you know, those plastic cutting boards, and on a bandsaw cut different pieces, various lengths for people and to provide on to do this technique. Because then you could wash them and stuff, but
Plastic what?
like those plastic cutting boards, you cut them up into like pencil-sized strips, and then cut them different lengths for different size mouths and stuff. But anyway, so what we're going to do with the mandible today is